So guys, let's start. In this particular project, we are going to do the SMS spam detections. Already we have collected some spam messages and some right kind of messages, collected data, and based on that we'll apply the machine learning model. Mainly we have applied here the Naïve based classifier model to detect the to classify the message. Okay, and after that we will evaluate it how much accurate our model is. Okay, just the theory part that till now we have discussed, we will implement that theory on that particular project. Okay, that's the simple job. And after making the calculus, after making the deep learning part, then we implement the computer vision project, deep learning part for that on our project. Okay, but I request you, please be patient with me. Till now the theory that I have covered, the simple, that is classifications model, regression model, such kind of simple machine learning model we will now we will try to implement in the real world data. Let's see it first. After that we will progress to the computer visions, NLP, some little bit interesting project already we have done in the NLP. Okay, in futures all or in future we also develop that kind of model. Okay, now it's our today's agenda is the spam message detections. So for that we have to this plan of attack that we are going to achieve for this presentation. Okay, so let's see how we'll achieve that job. So first thing that we have to do, you have that simple, importing the required library, then we have to read that data, then we have to pre-process that thing, then some EDA kind of things we have to do, means that exploratory data analysis. After that we will implementing that back of words. In previous video you have seen I have applied the TF-IDF vector, such kind of things. Now in this particular video we have applied the back of words approach. After that we will pre-process the data. After pre-processing it, we will apply our machine learning model and then we will evaluate it. Okay, let's go to one by one. So let's copy the name first and let's achieve that first, this step. Okay, let's go to our file. Yes, I have already created the folder and the data sets that I have already pasted here. Let's see the data set once. So this is our data set. In the data sets there have two columns, one is V1, another one is V2. In V1 we have the class label, it is the ham message or spam message, and it is the text. Okay, and based on that label we have to classify our text. That's our job, and for that classifications we are going to apply here the Naïve based classifier. That's simple, so simple. That's just for today's. Okay, I think you will understand. Now let's create the Jupyter notebook first here. Let's create it, the Jupyter notebook. Yes, it's take some time to open. Let's go to that particular folder. Yes, I have already created 11th one. Here we have to create the Jupyter notebook. And the name that I have copied, let's paste here. Yes, now let's copy the first job that we want to, importing the libraries. Yes, now let's show first that the most of the time that I have used the NumPy, pandas, is Scalon library and NLTK. So here mainly we need here the NumPy, pandas and NLTK. That's sufficient. In future so we require some more library, then we import that. Okay, so let's import that first primary library. Import NumPy HNP. Next we have to import the pandas HPD. Okay, now we have to import the NLTK library. NLTK library. That's all. Just a minute. So after that, we have to read the data set. Okay, let's read the data set. Let's make it as a heading. Let's run it. So for that reasons, we have to already panda we have imported. We have to read. So SMS, it's our SMS data, SMS, and we have to read it as pandas frame, pandas. What actually, guys, you can see it's our CSV file, the CSV file. So for that reasons, we have to call read CSV. Press the tab button, then you will see READ. Yes, read CSV. Then you have to call the dataset name. That's copy from here, spam.csv. And we have to encode it. Guys, why we have to encode it? Just see the data frame, then you will understand. Yes, guys, you can see there have lots of various kind of words. Suppose if we take that one, yes, this text, if we take, you can see, guys, this type of words we have, the various type of words we have. So for encoding purpose, we have to use the encoder. So in general, so here we have used the Latin encoder. Okay, so let's try in yourselves using the various kind of different encoder, then you will get different results. Just take it as your homework, then you will understand. So for that particular for myself, I have used here the Latin encoding. Let's Latin. Okay, let's try to explore that encoder in yourselves. Just Google it, read CSV encoder, then you will understand there are various lots of encoder and what is which importance. Let's try it. Let's try to explore in yourselves, then you will understand more better way. Okay, so that's all. Now let's read that file first. Our data set name is sms.8. Sorry, SMS. Let's see it first, header first. Yes, guys, you can see here have how much column there have 1 2 3 4 5. So only we need these 2 columns, these 3 columns we don't need. So for the reasons, first we have to delete that 3 columns. Okay, so let's delete it, because you can see, guys, it's null value, NaN value, not a number. So first, that's all, we have to remove that last 3 columns. So let's remove it first. So dropping that, for dropping it, we have to SMS data will be SMS dot drop. Okay, which column we are interested to drop? Let's 3 column, these 3 columns. This for first column, this for second column, and this for third column. Let's copy the name. Let's paste it one by one. Yes. And one thing you will notice, guys, after dropping it, we don't need to see here the V1, V2. Let's change the column name. So how we'll change it? Now let's update it. The column name SMS dot rename. And now our columns that we are going to here, COLUMNS, columns. So which value we want to change? That the first v1, we're going to change its name as what? It's the label. It is the label of the message. It's the ham message of spam message. For that reasons, let's call it label. Now next, that we're going to v2, and let's name is as it's our text. This is our text and this is our. Now if you see the header of that SMS data, then you will understand in yourself. Sorry, why it's shown here unnamed 2. Yes guys, I have done that mistake. Drop, I have to, yes, sorry for that. Need its axis defined, we have to define in which axis we have to drop. Stone. Yes guys, now you can see 1 is also here. Why is 2? It should be 2. Sorry, 4. Yes, it's why these things happen and is not found. So let's run from the first. Yes, it's okay. Now let's run this one. Now you can see. So I have now dropping that 3 columns, and we will update that first 2 columns name. First column name, that we have written here the label, and the second name is the text. Okay, that's simple. Now 1 or 2, let's explore the data, then we have to achieve that. We have to plot it. So before plot, let's explore it. Let's explore the data. Let's explore it. So for exploring, first let's check what are the number of rows that we have on our data set. So let's check the print number of rows. What is the length of our data set? Yes guys, you can see total number of rows we have 5572 in our data set. Okay, now let's see, let's count that how much ham message we have and how much spam message we have. Let's explore it. So let's count it. For that we have to use that count. Which count we have? Label count. We have want to interest the count of that label column. Its value count. Value count. Okay, value count. Yes, that's all. Let's run. Yes guys, you can see in our data sets total we have 5572 rows. Under a row we have ham message 4825 and spam message 747. So if you summed up, then you will got this total message. Okay, so let's run in yourself. Let's compute the sum. Let's open the calculator. Let's sum up 25 plus 747. Yes guys, you can understand. Yes, so that's all. Now let's explore the descriptions. What are the different count, what are the different type of unique values for each column. Let's explore this type of things. So for the reasons we have to describe our data set. Describe. Here you can see the number of rows we have 5572 for the label and for the text. The unique value for the label column is 2, that is ham or spam, and the unique value for the text column is 5169. Okay, and the top value here for the label column, the top number of value is ham and its occurrence frequency is 4825, and for text data the maximum number of occurrences value is, sorry, I will call later, and its number of frequency is 30. Okay, I think you'll understand that simple thing. So in the text column there have the more text, they have repeated many times, so for that reason its here unique value is 5169. Okay, so let's see the, let's explore the first the length. Let's add a new column length where we will add the length of that h text, of the h text. Okay, let's add it. So for here we have to add one column. So SMS, let's column length, the length, it's our column name. Now our SMS data, which value we have to, based on that text column we have to apply its function length. That's all. So what I have done, I have just created this new column length, name its length. Then we have to take that text column and we have applied the length function for each row on the text column. That's simple. If you see our data set, then you will understand what actually happened. Yes guys, you can see here. So the first row, its message is ham message, and number of text they are have, the length of the text is 111. Second row, it's a ham message, a text is 29. Spam message, its length is 155. That's all. So now let's doing some basic EDA. Basic EDA means basic exploratory data analysis. Let's doing that job. So for that, for plotting purpose, so visualize that thing, I will call that portions for plotting. Let's make a title first. Okay. Now let's import the necessary libraries. Import matplotlib, pyplot, hplt. Okay, that's the simple library. Now let's import the Seaborn library. Seaborn also necessary, so they have lots of important plot. Finish. Okay, now let's first plot the length, how much distributions of the length each. Let's plot it first, the length. Okay, SMS data, then we have interest that column name length. Okay, now we have to plot checkpoint, sorry for that, plot. Suppose let's the plot, and what are the thickness, let's beans to 50. Let's see it, then we'll understand, and let's wait kind of the plot each, what happened, kind each equals to its histogram that I want to plot it. That's all. Yes, let's see. Yes guys, you can see it's our plot, it's the histogram plot. So the maximum number of frequency on that length is this one, 14. Okay, and most of the times it's clears. That's all. So most of the cases, if you just zoom that one, if you just size that plot, see plot, then you will see what is the size functions here. If you want to increase that parameter, data x, y, kind, x, subplot, x, layout, fix size, it's 15 by 15. Yes guys, you can see. So most of the what's it, 0, 1, 2, I think 2, yeah, 10 it will be. Most of the time the length of the text are occur 10th its length. Okay, that's all. You will, I think you will understand, you will explore yourself. That's for now. Let's distribute that, the highest length for the humming message and the maximum length of the spamming message. Let's explore it. Okay, I think let's decrease the height some little bit. Let's 10 by 10. If I make it 10 by 7, it's okay. It's framed in one window. Okay, so it's for the mixed message. Here we have to take on the mixed message for the humming and the spamming. Let's divide it. Let's differently plot the humming message first, then we plot the spamming message. Okay, let's plot it. So same thing, same message that, but here we apply the different type of. Length plot. Let's remove. We want to plot the histogram, and our column will be, first the column length will be what, a length. That's our first column. That's based on that length we are going to organize our plot by, based on what, based on that label value. Okay, now let's define that binds. It's same. Let's decrease the figure size. Let's decrease the figure size. Suppose I am decrease it as 10 by 4. It's set. Let's run it. That's all. Let's little bit zoom that one. 15, 8. Yes, you can see this is the humming message, this is the spamming message. For humming message, the maximum length here, it will be near about 10 to 20, between 10 to 20. It's maximum length. But spamming message, the maximum number of messages that have its length is between near about 150 to 180. I think it's 150 to 160 maximum length. Okay, I think you will understand. For humming message, it's not a large message. The maximum number of messages that's occurred in the humming message, its length is near about 10 to 30, between that. But for the spamming message, maximum length is so much high. Okay, I think you will understand from that picture. Just pause that video and try to analyze yourself, then it will be more clear for you. Okay, now let's see some more important. Let's first just see, guys. Here label is the two level we have. It's and a text level. Then we have to convert the text into a numerical format. That's because at the end of the day, what do you have to do? You have to apply a machine learning model. So for that reasons, we have to encode it. So encoding that thing, for that reasons, we have to apply. For humming, we have applied 0, and for spamming, we apply the 1. All. Let's apply it. Let's encode that thing. So you can for encoding you will apply the various lots of library there I have already, but you just apply it first manually. So here we will apply it manually. So how we'll do that? Let's see. So SMS, this is data set. We have apply the functions, log functions, and for each row we will apply it. And the level, we apply that things on that particular level. Okay. And our SMS dot label label label, and we have to apply a map function. Okay, which map the functions is like that. So our key value is ham. For ham key value we will apply 0, and for spam key value we will apply 1. That's we will apply 1. Now if you see the message, then we understand. Sorry, see the data set, then you will understand what happened actually. Let's run it. Yes guys, you can see now label is converted from the text to numeric. Okay, here in the place of label ham we have applied 0, and in the place of spam we have applied 1. Okay, I think you will understand. That's all. Now guys, I think till now you will understand the thing. Okay, now let's implement the backup words on the text of that. I think you have known the what is backup words in theory, but already I have discussed in details everything step by step discussed. Now apply that thing on here. So now let's implement the backup word. Okay, let's make it as a heading. So one thing guys, for implementing the backup words we need that the library sklearn library. We use here the sklearn library. So for that reasons we have to import that first sklearn. So already we have installed it, so far we have to call that sklearn. That things we have to use the feature extraction model, feature extraction, and here we have to take that text word, text. Okay, here we have to import that count vectorizer. Sorry, what happened? Count vectorizer. Okay, so we have to now let's take it as count. Paste that thing on here. Now we have to feed that count functions on our data set. Okay, let's feed it. So where we have to feed that one, we have to feed that one onto our data set. So here which data? Our data is actually here guys, our data is our this text. Okay, we have to feed that control feed that count vector. Okay, let's see. But guys, one thing that you have to notice here, we have applied that count vectorizer to move the text into a vector format. First we have to split our data sets into a train data and text data. After that we will apply that things will be better for us. Okay, so let's first splitting the whole data into the training and test data. So for splitting it we need that library. So from sklearn and that model selections we need from here. Model selection, we have to import the train and test split. Okay, and here we have to take that x train, then we have to take that x test, Then we have to take that y train and y test. So here we have to apply that train test split. Sorry, what happened? X train, y x test, y train, y test. Okay, that's all. Now, what will be the first X train? First train value will be our this lab text data. So SMS, this text column. And that label your target value. Our target value is our label. And we have to define what will be test size. So here I have taken here the text size as 20%, okay, and 80% for the train size. And at always random state will be what? Random state 1. Let's take random state. Random state here will be 1. That's all. Let's run it. Yes. Now we have splitting our whole data sets into the train and test splitting. Now after that we have to apply that count vectorizer onto that our training set. Okay, because only we have to convert that this text part. Okay, so for that reasons we have to apply that count vectorizer on that training set. And means training set this part, only this text part. Okay, means X train. We have to apply only that things, only the X train and X test, not Y train. Y is our target value. X train and X test. So let's apply it. So for that reasons we have to train data, we have to update our train data. X train data will be to apply that count and have to fit it, transform, which things we have to apply these things extra. Similarly for what? That's we have to apply for the text data as well. Yes, that's all. Let's run it. Now, after if you just print that train data, then you will understand it's now converted into the vector format. Sorry, yes, actually it's a Sparse matrix. For that reasons it has not a head file. Okay, because we have applied that words back of words. Okay, so for that reasons this text data now is converted into a Sparse matrix, because in theory part I have already told you what is the Sparse matrix and how we converted that things, everything in details I have elaborated there. Just if you forget it, just go there this series and just follow that one. Okay, that link I have already pasted on the description. Okay, just go from there. Okay, so that's the we have already ready. Now let's implement the Naïve ML model. Now implementations of ML model. Let's make it as heading. Okay, let's run it. Now let's apply it. So we have in previous we have already discussed that that step done. We have to going to apply the Naïve. Mainly we have applied here the Naïve classifier. Okay, so for that sense from sklearn already that in sklearn model that things already available. Naïve base. From this we have to import that multinomial Naïve base. Okay. So that our model now is our this multinomial Naïve base. That is our model. Okay. Now I have to feed that model now dataset. So model dot feed. What is our dataset? X train and Y train. Sorry guys, it is X train and target value Y train. Yes. Now let's run it. So one thing guys here, okay, I think let's run it, then we'll see how we'll improve that thing. Yes, that's all. We have trained our model. Now let's evaluate that model. What are the precisions of that one? Let's predict that one. Show our prediction is. Let's see the prediction. What the prediction? What is the prediction? Prediction will be our model dot predict. Let's pass that. What is our that train value? Y test. Sorry, we have to pass that X test value from here. And predict the test. Okay, that's all. What happened? Dimension mismatch. X test, Y train, Y test. So why this happened? Let's see why the dimension is not matched. X test. So guys, sorry guys, we have to pass also the Y value. Sorry, it's my bad. We have to pass here that Y test also. That's all. Let's run now. Predict takes 2 positional argument, but 3 were given. Let's see the predict function first. X arrays like a shape, n features, n samples, n features. Okay. Okay, what happened? So guys, what happened? I think let's run again. Yes guys, you can see here this value of the that shown that it's dimensional mismatch. Why it's a dimensional mismatch? Because if you see that extrinsic, print that extrinsic and extrinsic shape, then we will understand it more better. In dot extrinsic and let's print it test shape. Then guys you will understand the different size, because 4457 and 77, because we individually apply that count vectorizer on the edge datasets. So for that reasons, in different time it will take the different size. So for that reasons, our model will give that not predicted accurately. So to remove that things, we have to apply that count vectorizer first in the whole datasets. After applying that count vectorizer on the whole text data, then we have to divide that things into the train and text. Okay. Now let's apply. The count vectorizer first onto that whole dataset. So our first let's apply it. So model.feed, we will just apply that step on here. Text will be what thing we have applied this text. Simple text data, and on the text we have to make that one. Now convert to fit dot transform. Why guys it's happen? Now if we just make that command, let's run it. If you want to see the extrain file, yes, sorry, it's my bad. Yes, it's my bad guys, it's a text, not the label. Text, it's my bad, sorry for that. So now it transform. Why this thing happen? Let's see. Yes guys, sorry guys, here we have applied that count fit transform. Okay, transform. Okay, now let's run it. Yes, now it's okay. Now instead of here SMS level, if you see that the text, only the text, then you will understand. If you just write that text, then you can guys see it's that same kind of. Now we have to apply that text in the place of the text. Now let's apply this text. Okay, I think you will understand why we have got that error. Okay, so it's also a better side to understand our model. Okay, let's run it again. Yes, now it's run. Okay, now that steps we not need it. Let's delete that step. Now if you just see that shape of the dish, now you can see its shape is that is the number of categories are similar, same. Now let's feed that model onto our data set. Now what happened? Yes, now it's okay. Now let's predict. Okay, now we have not got any error. Now let's print the predict, then you will understand. Let prediction. Zero 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 zero. Okay. Okay, that's all. Now let's evaluate it. Now let's evaluate its score, what amount of score it has, accuracy score, precision score, recall score. So let's try to explore the various kind of score one by one. Okay, let's explore it. So for that reasons we need from the scalar, from scalar we have to take that matrices and we have to import that accuracy matrix, accuracy score, we have to import that precision score, we need here the recall score, and also we need that F1 score also, F1 score. That's all. Now let's run one by one. Let's print one by one. So first we have to print that accuracy score. Let's make it more beautiful. And what will be the accuracy score? In that place we have to also here that value we have to take in that value format and that thing we have to pass here, accuracy score function. Accuracy score function we have to, and here we need to pass what is the accuracy y test, that's the actual value, and our precision's value is this one, predictions. Okay, that's, let's run. So this is our accuracy score. Now let's, what is the precision score? I think you will understand what is the actual accuracy score mean, what is actual the precision score mean, what is recall score, F1 score. In theory part already we have discussed that things. I'm not going to discuss again here. If you just forget, just go there, this theory part, go there in the theory sections, then you will understand these things in more better way. Precision score, here we have to pass that function. Now is it print have closed, yes, okay. Now we have to paste our recall score. Sorry guys, recall score. Yes, recall score. Now after that we have to take that F1 score. F1 score. So let's run it. So guys, you can see that's at the precisions, that's at the score of our model that I have used here, the Naïve based classifier, simple multinomial Naïve based classifier. So as your requirement, you can take different model also. Suppose let's define a model here. Suppose let's, I am going to here, suppose let classifier max mean Gaussian Naïve base I have applied here. Instead of Gaussian Naïve base, just write here the Gaussian Naïve, multinomial Naïve base, just write it the Gaussian Naïve base. Sort of first, but dense is required. So Sparse matrix here is not working for Gaussian Naïve base for that reasons. It's shown here. So let's apply different model. Logistic warming classifier Bernoulli Naïve base. Let's, I'm applying the Bernoulli Naïve base. What happened? Yes, now let's predict. Let's score, see the score. Again I have to take that one and paste here. Then you will see. Now let's now you can see we have improved some little bit. If we apply that, our accuracy score is improved 98%, precision score is improved also 98%, but recall score we have decreased 90% and F1 score also increased. So that's for, you see, just make it print, it is for our multinomial Naïve base. Okay, and it is our, for it is this is for our what? This is for our Bernoulli Naïve base. Bernoulli Naïve base. Let's run for the multinomial Naïve base. Yes. What happened? Okay, I have to again make that prediction. Yes, guys, you can see it's our multinomial. Now let's apply the neural network. What happened if we apply that neural network? I apply here classifier, MLP classifier. It is a MLP classifier. Let's apply it. Yes, it's because it's neural network. It takes some time. Just wait. See, guys. Let's wait. It takes some little amount time. It's depend on your system. If you using that Google Colab, then it will. But I have used my own system. It's not so much configured. It's a simple laptop. We have used simple 8 GB RAM and SSD, 500 GB SSD and 8 GB RAM. If you use the GPU, it will be more better. It's take little bit time. So how will understand it's actually running or not? Just see that logo first. It's running, guys. Because of that, and then here you can see it's that star also. So yeah, if it is completed, then you show here the number. Okay, so let's wait. Let's wait some little bit. Yes, guys, I think now you'll see our model is ready. We have already trained. Okay, that's the actually it's in that one. It's taken that in default. It's taken that activation function ReLU alpha value score is this one, batch size this one. When we learn that neural network deep learning model, then we understand what that kind of thing. Let's first understand this is. So this kind of parameter it is default. It's taken. Let's predict that function. Yes. Now let's see again. Okay, here it will be our MLP multi-layer perceptron classifier. Let's see the score. Yes, guys, you can see efficient core 100%, its accuracy core 99%, so recall score 94%, and F1 score 97%. Okay, so that's all about today. So I think you will understand how to detect that spam message. If you want to deploy that model on some environment, some if you want to interest some website that we apply that model. So in one of our video we'll see how to deploy that model on that end user. Actually at the end of the day we have to use that model for our users, and user don't understand what happened, what is accuracy score, that just got the result what actually I've done. Okay, so for that reasons we have to apply that model on that user interface. So in next video we will see how to apply that model that we have that model that we have built, this simple model. First we have to save that model in a pickle file. Okay, after that we have to use that pickle file and we have to make some beautiful interface. We'll make some beautiful interface and user just paste that message and they will got that output. So let's try it. Let's try, why not? Let's try some message. Suppose I have taken some input. Suppose let's have taken okay, this is a simple message. Okay, and let's pass that message into the model. While model will get that output. Model dot what thing? Feed, go parameter, learning, rows, maximum, layer, power feed, scores, solver. That's at the. So suppose let's simply pass that input. MLP object is not callable. why, let's see why this kind of happen. Okay guys, why? Actually because this is this type of error occurred because guys, you can see I have converted the text into the sparse matrix. So for that reason we have to pass a sparse matrix into here. So first thing we have to just pass that vector into that count vectorizer, feed count. We have to first text, we have to first pass it. So now our input will be okay. Text string object receipt. Okay. No problem. If I just pass it, invalid syntax. Again, if I pass it, iterable over raw text document expected. Okay, we have to pass a document here. Yes, here we have to pass some document. So for that reasons we have not passed this. We have to pass some document. Let's make a list. Yes. Now let's pass it. Okay. Now if you see that, what is the size of our input? 1/2 because we have 3. So to make that sparse matrix, so one thing guys, we have to take that sparse matrix on our data corpus here. From here we have to sparse that one, then we will got that one. Okay, now where just here we have to pass that text plus we have to pass that input. See, let's call it where is it I am, yes, let's take it. Yes, now if you run, yes guys, now if you see that save, text end is not defined. Yes, one cross this value we have, show how much total value 5572. So 5572, if I print it, it's not, it's from starting from 071 it will be, yes, 5571. It is now our new input. Now let's run. Yes, now we have to pass that input here. Now we have to pass that input onto our model. If you see why model.input MLP objects is not callable. So guys, why these things happen? Okay guys, sorry, actually this is our input, we have to predict that input. So sorry for my bad. We have to predict it, apply predict. Now you can see we have 0. 0 means what? 0 means our data is 1. 0 means it's a harm message, and 1 means spam message. Just take some copy of the spam message. Just take what is, suppose let I have taken this type of words. Suppose let's I am taking till now this one. Okay. Now let's run it. Here let's make it. Where is it? Yes. Now paste that here. Now let's make it. Now this is our input. Now if we make it, what is? Array thanks. For you, this is our array. Receive the data either -1 or evenly minus. That's value we have taken here. Thanks for subscriptions. This one. Okay. Now if just take that message here. That's simple. This message I have taken as input, and now we have convert that as a word to vehicle. Okay, feed transform word to vehicle. After that, we have to extract that word to vehicle from our end data of the text. Let's run again. What is the text size? Just make it as comment first. Now let's say what is the text size. Yes, 5572. Okay, no problem. Yes guys, needs our input. Now if you want to see the input, yes, now it's not already in say sparse matrix. First thing that we have to take it as a sparse matrix. Okay, so for I will take that this is our input. We have to transform this text. Let's run. Now let's run this one. Now let's go here. Let's run this one. Yes, now you will give that one, you will take. Yes, it's taken that 0 means it's a harm message. Now guys, if we take that all the message, okay, now if we paste that message here again, that message, if you paste that message here again, okay, now just run it, and see is it sparse matrix or not. Now it's a sparse matrix. Now let's predict it. It's array 0. Five stored elements in the crossed sphere row format. Why always it's saying 0? Now if it's remove all the things, only these 3 things I have taken here. Okay, here 5 stored element. If we show here is also it's shown, it's the 5 stored element. But why? Let's analyze it. Now guys, let's explore through a spam message. I am totally entire copy a spam message. This is our, suppose let's copy another one. This is a spam message. Yes, it is also a spam message. Let's copy this spam message. Now let's paste as the input vector. Here I have pasted this one. Now if we just run it, yes, now if you see that, now if you see the text length, yes, total 5572. So the last text we need. So here 5571, this is our last text, this is really your input. Yes, now if you see that input size, yes guys, here also, now let's run this input. Yes guys, you can see it's a 0. Why? Guys, just see what is the index of that one, total how much element we have. If I just remove that, if I just remove this input, if I run it, total 5572. Okay, 5572 number of text we have. I think after adding this text, why it's not taken? Suppose let's have taken this one. Will be okay. Now if we run it, same text, if I little bit change this one, then if I run it, just see guys, I think SMS text, I think it's have to pass that thing into vector input. Okay, now if I run it, what error? Series has no attribute lower. So take it. Okay. So, okay guys, no problem. Now let's try to analyze that thing in more clearly in a new paragraph. Here we have want to analyze that thing. So this is our SMS text that we have counterized, that this is our text. That text we are actually going to we have applied on that text that what to vector. Okay, now the same thing, that input text also we have to taken. Suppose let's have taken some input new text. So if you see that length of that text is 5572, just see it. Now suppose let's have taken a new text as the input. Suppose I have taken these as random, what I have taken here. Okay, now I think let some text from that here, from the spam text. I think it will be better, because the size of the what to take we have to constant. For that reasons to take this one, I have taken this one. Okay, now we have to add this text into our whole data text. Now the data text is equals to concat here we have to concat that one, that text, input text to that particular text. So guys, let's see, it's very simple thing, let's explore it. So suppose it's the data, and now let's see what data is, what type of look like. Yes, it's the data, the last index is 5571. Now we have the end of that loop, we have to input, we have to add our input. So for that we have to add data dot ilog functions we have to use, and on that place we have to use that what the length of the data dot index. Okay, we have to what we have to want to index this one, this text we want to pass. Now let's run it. Now if you see our data sets, then guys you can see first it has 5571 number of rows, but here number of row is this, and at the end we get this one. Now on the data sets, let's apply the count, let's apply that one, count Productionizer, count vectorize, this one, let's apply it, this count vectorize data dot, what is that particular code, count fit transform. This is our text. Fit transform. Now we have to apply our data here. Yes, now if you see the text, it's a Sparse Matrix 5573. Now here we have to take our input will be text of what, this 5572 is text. Yes, now let's predict that text. Model dot predict this input. Let's predict it. Guys, you can see it's a spam text. It's predicted. It's a spam text. Okay. Now let's another one. Let's predict another one. Suppose let's in my okay. I am this okay, this okay, this. Let's call it. Let's first run this text. Let's see our data. Let's ilog it. Okay. Okay. Now let's run it. Yes. Now I have pasted here. Now let's tokenize it. Yes. Now if you see what is the size, guys, it has now size has increased. Now if you pass it, guys, you can see if you pass that, it's shown that error, dimension mismatched. Yes, guys, you can see the dimension mismatched because our trained model is based on that previous dimension, that is 8672, but our now that the data that we have passed, its dimension is changed because in our data corpus this 2 word is not in our dictionary. So for that reasons, it's automatically increase the dimension for adding that 4 words. These 4 words is already in our dictionary, but this 4 word is not in our dictionary. So for that reasons, it gives that such kind of mistake. Okay, so I think you will understand this type of analysis. Okay, how these things happen, and lots of error we have seen here, and we will also eliminate that error, and at last that's the main thing, at last we understand why this kind of error we have got here. Okay, that's the main thing. I think you will understand some kind of concept. Okay, as we progress we will see how much deeply we have entered that things, how we'll analyze that thing in more deeply. Okay, we will see that things in your future video. So guys, that's for today. I think you have enjoyed the whole sessions. If you find some concept, if you find some value from that particular video, please like it and share those who have needed that particular type of things. Okay, so bye for till now. So we will see tomorrow using some new concept, new type of explorations, new type of projects. Okay, bye, see you soon.